Welcome to The Explainer. Today, we're going to talk about the brains inside our most powerful industrial machines. And we're going to ask a really important question. Who should get to hold the keys? So let's just start with a thought experiment. Imagine your company spends, I don't know, millions of dollars on a brand new state-of-the-art machine. It's the heart of your whole production line. But then, what happens when its software gets a little old? Or you just need to make a simple change? You find out you're completely locked out. You're at the mercy of the original manufacturer, who, by the way, might just tell you, sorry, time for an upgrade. A very, very expensive upgrade.
You know, that scenario isn't hypothetical at all. It's a daily reality for so many businesses. It's a problem that we call the sealed black box. And for decades, it's just been the standard in the world of CNC. You know, computer numerical control. That's the software that tells our most precise manufacturing tools exactly what to do. Let me put it another way. It's like buying a new car, but the manufacturer has literally welded the hood shut. If anything goes wrong, even something tiny like a loose wire, you can't pop the hood and fix it. Nope. Only the original dealer can, and they get to decide when, how, and for how much money. That is the exact situation we've had with traditional CNC control. For years and years, these proprietary, closed-off systems were basically the only game in town. I mean, sure, they were reliable, but they were also completely rigid. But now, a new idea is really starting to gain some serious traction, an open-source alternative. And it promises a whole lot more flexibility, a much longer life for these expensive machines, and way better integration with all the modern tech we use today. And this old, closed approach, it creates some very real and very high hidden costs. For starters, you're completely dependent on your vendor for any little customization. Trying to integrate modern tools like data analytics, it becomes a massive headache. You can't see the internal logic, so when something goes wrong, troubleshooting is basically just pure guesswork. But the real kicker? Perfectly good multi-ton machines, we're talking incredible pieces of hardware, end up getting scrapped just because their software is out of date. It's an incredible waste. Okay, I get it. The term open source can sound, well, a little scary, right? Especially when we're talking about machinery that has to be incredibly precise and, most importantly, super safe. So let's get really clear about what we actually mean by open source in a serious industrial environment. Industrial open source is not about chaos. It's about having access, but under a very specific set of defined rules. All it means is that the system's design and its logic are transparent. Engineers can finally look under the hood. They can inspect, they can understand, and they can build upon the system, instead of just treating it like some frustrating, mysterious black box. So, and this is the crucial point. Let's be crystal clear about what this is not. We are not talking about turning a factory into some kind of Wild West science experiment. Industrial open source does not mean unsafe systems. It absolutely does not mean that just anyone can waltz in and change the core safety features. And it is definitely not some hobby-grade software. This is about professional-grade transparency, period. All right, so now that we've hopefully cleared up that misconception, let's get into the good stuff. Let's break down the advantages, because this open approach really delivers 4 key benefits. And this is where you start to see the incredible value. Yep, 4. 4 foundational pillars, and each one of them fundamentally changes the entire relationship between a manufacturer and the machines they depend on. Okay, number 1 is transparency, and that directly builds engineering trust. I mean, think about it. When your engineers can actually see how a controller works, they can diagnose problems in a fraction of the time. They can validate safety protocols themselves. They can maintain the system. It replaces all that frustrating guesswork with solid, real-world engineering. Second, and this is a big one, is longevity. The physical machine itself, you know, the steel, the motors, the hardware, that stuff is built to last for decades. Open systems mean that the software, the brain, can be updated bit by bit, keeping it modern, keeping it secure. This makes sure that the entire machine, the whole thing, lives up to its full potential lifespan. And this chart right here, man, it just lays the whole problem bare. With the old proprietary systems, look at that giant gap. The short lifespan of the software forces a multi-million-dollar machine into retirement long before its physical life is even close to over. What openness does is close that gap to get those 2 lifespans in sync. The third key benefit is all about breaking free from vendor lock-in. This is huge. It gives manufacturers the freedom to integrate the absolute best tools for the job, even from third parties. They can build their own custom features and adapt super quickly in a competitive market, all without having to go ask a single supplier for permission. And finally, the fourth benefit is all about future-proofing. All the really exciting tech that's coming down the pipe, we're talking AI-assisted machining, digital twins, advanced data analytics, you can't just bolt that stuff onto a rigid, closed-off system. It just doesn't work. An open platform creates the foundation you need for these future innovations to actually have a place to live and thrive. So, the benefits are pretty clear, right? But the big question, the one you've probably been thinking about, is still there. How in the world do you get all this amazing openness without compromising the rock-solid safety and the micron-level precision that these machines absolutely, positively must have? Well, the answer is actually pretty brilliant. It all comes down to a smart, layered architecture. Okay, think of it like a three-layer cake. The bottom layer, that's where the hard, real-time functions for motion and safety live. That part is locked down tight and strictly protected. But the layers on top, the ones for system logic and user interfaces, those are specifically designed to be open and configurable. So you get that critical stability at the core with all the flexibility you need on the surface. It's the best of both worlds. Of course, a revolutionary change like this doesn't just happen overnight with the flip of a switch. The companies who are really leading this charge, like Radonix, and we're drawing on a lot of their research here, they understand that you need a responsible, step-by-step roadmap to get there. And their approach is really a perfect example of how to do this right. You see, first you build a foundation of proven, rock-solid reliability. You have to start there. Then, you build a modular architecture on top of that solid base. And it's only once that platform is mature and totally stable that you begin carefully opening up those extensible layers for customization. It's a smart evolution, not some reckless gamble. You know, this entire philosophy is just captured perfectly by the Radonix R&D team themselves. They said, in industrial CNC, openness is not about chaos. It is about control, clarity, and continuity. I mean, that just nails it, doesn't it? It really says it all. And that leaves us with one last big thought to chew on. As all of our technology becomes exponentially more complex and our machines get smarter and smarter, are we going to reach a point where transparency is no longer just a nice-to-have feature, but the absolute non-negotiable price of trust?